Good morning, everyone. So today we're going to go a half step further with elimination. So you guys have gotten pretty good for the most part at eliminating problems in which the coefficients are already opposite. So if this was a 4 and this is a -4, you guys haven't had too much trouble adding those together and getting rid of them. You've also done pretty well when you have something like a -4x here and a 2x here, where you can just double this equation so that this reads 4x, and then you could combine them and be good to go. But you might notice that neither of those will work well for this system of equations. If I'm looking at this one, I can see that my x I couldn't just double to get to the -4 because that would make it larger than this -4. I'd have a 6x instead of a 4x. And if I'm looking at, okay, well then I can maybe cancel out the y, well I'd say, well I want this y to have a 5 in front of it. Well, there's no very nice number to multiply 2 by to get to 5, so I'm going to end up introducing a lot of decimals and it's going to get really messy. So what we're going to do is we're going to learn another technique to solve this with elimination. And in this one, again, we could eliminate either the x or y. I'm going to look at eliminating the x, and I'm going to do that rather than the y simply because there's already a negative in front of one x and a positive in front of the other. So it's probably going to be slightly easier to get rid of. Alright, so here's what I'm going to do. If I want the coefficients to be the same, I essentially need to find what number I could multiply this one by and what number I could multiply this one by so that their coefficients are exactly the same. Well, there's kind of a nice way of doing this, and that is, why not multiply this one by 3 and this one by 4? Because I know that 3 times 4 and 4 times 3 are the exact same number, 12. So I'm going to do that because that's going to get rid of one of my coefficients. So here's what I'm going to do. I'm going to take this coefficient of the x and I'm going to multiply my equation down here by it. So this whole thing is going to get multiplied by 3. And I'm going to take the coefficient in front of the x, that 4. I'm actually going to keep it positive because remember I do want these two things to be opposites. And I'm going to multiply this equation by 4. So notice I'm just flip-flopping the coefficients that I have. Now, when I distribute these, here's what I'm going to end up getting. When I've distributed the 4, I'm going to get 3 times 4x, which is 12x, plus 5y times 4, which is 20y, is equal to 6 times 4, or 24. In my second equation, distributing that 3, I'm going to get that 3 times that -4x. Don't forget your negative in this case. And that's going to give us a -12x. Plus, and don't forget to distribute to everything in here, 3 times 2y, which is equal to 6y, is going to give me an answer 5 times 3, or 15. Now again, don't forget to distribute to everything because otherwise we've changed the equation. And this equation is telling us specific x and y values that work together. So if you change it, if you unbalance it by maybe forgetting to distribute to one of those, you actually start talking about different x's and y's. So these are equivalent to what we originally wrote, but now when you look at them, we have the same x's, or the same coefficients for our x's. So what I can do now is solve using elimination. So I'm going to add these two together. Since these two are opposite, 12 plus -12 cancel out, and remember that x goes along with them. 20 plus 6y gives me 26y, and 24 plus 15 is going to be 39. Here I divide both sides by 26, giving me a y value that is equal to 39 divided by 26, or 1.5. So now that I know what y is, I'm back to my firm and comfortable grounds, because all I need to do then is substitute this back into one of my equations to solve for x. And let's just quick do that with one of our original ones over here. It actually doesn't matter if you pick one of these or this one. I just like this one because it has all positive numbers and they're fairly small. So substituting back into my first equation, I have 3 times x plus 5 times my y value of 1.5 is equal to 6. 5 times 1.5 is going to give me a decimal, but I mean, we're talking about a pretty small or pretty normal decimal. 0.5 isn't so bad because that gives me 7.5. And I end up with 3x plus 7.5 is equal to 6. So divide both sides, or sorry, subtract 7.5 from both sides to get 3x is equal to a negative 1.5. Divide both sides by 3, and we end up with an x value of negative 1/2 or negative 0.5, depending on how you want to write that. Both of those are the same, and I don't mind if you're using decimals here, especially when it's an exact answer still. So our final answer, if we combine these two things, is that these two lines share the point negative 1/2 or negative 0.5 and positive 1.5 or positive 1.5. So you could write this as xy in a coordinate, which is a lot of times a little bit neater to work with than the x equals y equals. Okay, so now that we have seen this method, I want you guys to return to the worksheet from yesterday. Now you'll notice on the back that there are a lot of problems that have this issue where they don't nicely cancel out, and you're going to have to multiply both equations rather than just one. Actually, sorry, I changed my mind. I want you guys to go to page 405 of your book and only do 3 of them, not the rest of that worksheet. What I want you to do is page 405, do 17, 19, and 20 using elimination as your method. And don't forget you're going to have to multiply both equations for probably all of these, though maybe there's one where you don't have to. Okay, that is due tomorrow. Please let me know if you have any questions. Have a great day.